Welcome and good evening. Tonight we will embark on a journey through the quiet cosmos. Let yourself settle comfortably, feeling the gentle weight of your body against the surface beneath you. Take a slow, deep breath, letting it out gently, and imagine the vast emptiness of space stretching around you. Silence, soft and endless, envelops you as we begin our tale. Every star begins its life quietly, in darkness. In the cold, immense reaches of interstellar space, clouds of gas and dust drift slowly, almost imperceptibly. These clouds are called nebulae, cradles of potential, vast reservoirs of hydrogen, helium, and specks of heavier elements. In their folds, life waits, not life as we know it, but the possibility of energy, light, and warmth yet to come. You may picture the nebula as a soft, glowing haze, suspended like a delicate mist. It moves slowly, stirred by gentle currents and the faint tug of gravity. Though it seems calm within this stillness, small fluctuations are taking place. Tiny regions of gas grow denser, gathering more mass, more weight, pulled gently toward themselves. These are the seeds of a star. As the cloud contracts, the particles collide softly, releasing heat. This process is slow, imperceptible at first, but persistent. Over hundreds of thousands, even millions of years, the center of this gathering cloud begins to warm. It forms a dense, hot core, glowing faintly in the dark. This is the protostar, the earliest stage of a star's life. A protostar is not yet fully a star. It cannot shine as we see in the night sky. It is hidden by dust, shrouded in a veil that softens its light. Yet inside, nuclear forces are stirring, and gravity continues its patient pull. The protostar swells, contracts, and rotates, a slow pirouette in the darkness. And there, in this quiet moment, the first whisper of life begins. Hydrogen atoms, pulled together by gravity, are preparing for a grand transformation. They will soon fuse, releasing energy in a dance that has powered the cosmos for billions of years. This quiet contraction, this invisible tension, is the heartbeat of creation. Close your eyes and imagine the soft glow of this forming star. Feel its warmth not in your hands, but in your mind, a gentle radiance spreading through the emptiness. Though distant, it connects to everything, every planet, every galaxy, every star that will one day light the sky. The story of a star begins not with explosion, nor with fire, but with stillness, patience, and quiet accumulation. In this chapter, we linger in that stillness, letting the vast, gentle forces of the universe settle in our awareness. A star's life is a song of time, unfolding slowly, deliberately, and beautifully. After long, patient contraction, the core of the protostar reaches a temperature so high that hydrogen atoms begin to fuse into helium. This process, called nuclear fusion, is the moment of ignition. The star awakens. Light begins to radiate outward, pushing gently against the inward pull of gravity. Balance is achieved, and a star enters what astronomers call the main sequence, a long, stable phase of life that can last millions or even billions of years. Picture this star floating serenely in space, shining steadily. Its light travels across incomprehensible distances, reaching distant planets, dust clouds, and the eyes of future observers. Though it may seem eternal, every star is mortal. Every star has a story, and its beginning is both quiet and patient. During the main sequence, the star burns hydrogen steadily. This is a time of calm and stability. The core produces energy, which travels outward through layers of gas. Some stars are small, faint, and cool, barely noticeable against the darkness. Others are massive, bright, and warm, dominating the skies of nearby systems. Each star has a rhythm, a pulse, a measure of time that it follows faithfully. Imagine standing on a distant planet, gazing up at this newborn sun. Its light is constant, a gentle presence in an otherwise silent universe. The warmth it provides is subtle, a reminder that even in the emptiness of space, energy flows, life is possible, and time moves steadily onward. Stars are not merely balls of gas, they are sculptors of their surroundings. The gentle push of their radiation shapes nearby clouds, slowly clearing paths in the dust, influencing future generations of stars. Massive stars, with their intense energy, can stir the interstellar medium, creating ripples and waves that carry the echoes of their existence far beyond their immediate vicinity. Even in this seemingly simple stage, life is complex. The star is alive in a quiet way, balancing pressures, regulating energy, and maintaining equilibrium. The light that escapes is a message, a gentle whisper of stability in a universe defined by change. As we drift alongside this luminous body, we notice subtle changes over time. Hydrogen in the core gradually diminishes. The balance between fusion and gravity shifts imperceptibly. The star ages, slowly moving toward its next phase. In this calm, measured progression, we see that stars are patient teachers, showing us the quiet art of persistence and constancy. Now, imagine yourself floating nearby, watching the star's light ripple across distant nebulae. You are not in a hurry. The star does not rush. Time here is slow, deliberate, and profound. This is the gift of the main sequence, a long, gentle phase in which a star teaches us about balance, stability, and the passage of cosmic time. Eventually, hydrogen in the core is depleted. Gravity gains the upper hand, compressing the core while outer layers expand. The star swells into a red giant, its surface cooling and reddening even as the core heats to extreme temperatures. Imagine a serene sun growing larger, its gentle light softening, bathing nearby planets in warm, amber glow. This expansion is slow, measured over millions of years. The star's atmosphere stretches outward, whispering against space like a quiet breeze. Any nearby planets experience the warmth and energy, a reminder of the star's influence beyond its immediate body. Inside, the core continues to burn, fusing helium into heavier elements such as carbon and oxygen. These processes are slower, less stable than the main sequence, and the star's life becomes more intricate. Layers of energy move outward, interacting with gases and magnetic fields, creating subtle waves that ripple across the star's surface. Stars of different masses experience this phase differently. Smaller stars like our Sun will expand gently, shedding outer layers into space, forming ethereal clouds called planetary nebulae. Massive stars, by contrast, prepare for a more dramatic finale, accumulating layers of heavier elements until their cores become dense, unstable, and ready for collapse. Take a moment to visualize the red giant as a calm, radiant presence in space. Its expansion is graceful, deliberate. The gentle glow spreads, illuminating dust clouds, icy bodies, and distant observers. Though the star ages, it does so with poise, demonstrating that even in change, there can be elegance and quiet rhythm. This is a stage of both beauty and contemplation. The outer layers, tenuous and delicate, drift into space, enriching the cosmos with elements essential for life. Carbon, oxygen, nitrogen. These gentle gifts from dying stars will one day become part of new worlds, new planets, and perhaps new life. The star's existence is thus not only a personal journey, but a contribution to the broader story of the universe. Imagine floating in the red light of the giant sun. You feel a sense of calm, witnessing a process that is immense yet silent, powerful yet gentle. Time stretches around you. The universe seems to breathe in harmony with the star's slow pulse. As the red giant reaches the end of its life, it begins to shed its outer layers. These gases drift outward slowly, forming a delicate, glowing shell known as a planetary nebula. Picture this as a soft, cosmic flower unfolding in space, its colors muted yet radiant. Blues, pinks, and golds shimmer gently against the blackness, a testament to the quiet artistry of the universe. The core left behind is hot and dense, a small ember of the star's former self, called a white dwarf. Though tiny compared to the once expansive red giant, it shines steadily, a quiet remnant of past brilliance. Its light reflects on the surrounding nebula, illuminating the drifting clouds of gas and dust. The formation of a planetary nebula is not sudden. It is gradual, almost imperceptible, taking thousands of years. Outer layers drift away in graceful arcs, spirals, and waves. Tiny shocks ripple through the gas, sculpted by winds and magnetic fields, creating intricate patterns that would seem impossible to imagine. Even in this final phase, the star gives to the cosmos. The expelled gases enrich interstellar space with elements forged over millions of years. Carbon, nitrogen, oxygen, ingredients for future stars, planets, and perhaps life itself, spread gently, silently into the void. Each particle is a quiet gift, traveling through space until it encounters new clouds of gas and dust, perhaps beginning the cycle anew. As you visualize this scene, imagine drifting slowly among the glowing nebula, each tendril of gas illuminated by the distant, persistent light of the white dwarf. There is no rush. Time stretches, and every moment seems to linger. The universe breathes in harmony with this gentle transformation. A planetary nebula is a quiet celebration. It is the star's final act of beauty, a slow, deliberate gesture that enriches the cosmos. In this softness, we are reminded that endings can be luminous, serene, and full of purpose. Stars much larger than the Sun follow a more dramatic path. After exhausting their fuel, their cores collapse under immense gravity. Within moments, temperatures and pressures skyrocket, triggering a supernova, a titanic explosion of light and energy. Though violent in cosmic terms, a supernova is also beautiful and awe-inspiring. Imagine a star lighting up an entire galaxy, brighter for a brief moment than all surrounding stars combined. The shockwave spreads outward, carrying heavy elements forged in the core, iron, gold, uranium, into the cosmos. These materials will seed future stars, planets, and perhaps even life. Before the explosion, the star swells into a red supergiant, its outer layers tenuous and unstable. The core, compressed and dense, is on the edge of transformation. Nuclear reactions push against gravity, creating tension, imbalance, and immense potential energy. And then, in a sudden brilliant flash, the balance tips and the star erupts. Picture floating in space, far enough to witness this supernova safely. The explosion is mesmerizing, like an immense cosmic firework frozen in time. Colors of blue, red, and gold swirl outward, the light traveling across millions of kilometers, reaching distant nebulae and future worlds. The universe listens, silent yet attentive, as the star completes its ultimate act. The supernova leaves behind a core that may become a neutron star, or, for the most massive, a black hole. A neutron star is incredibly dense, a sphere no larger than a city, yet containing more mass than our sun. Its gravity and magnetic fields are intense, its rotation rapid and precise. Black holes, by contrast, are regions of space where gravity is so strong that not even light can escape. They are the ultimate endpoints, invisible yet profoundly influential, quietly shaping the motion of nearby stars and gas. Though mysterious, they are as much a part of the star's story as its glowing birth. In this chapter, we linger on the concept of transformation. Even in apparent destruction, there is creation. The star, in its final act, spreads life-giving elements across the cosmos, ensuring that its energy continues in new forms. The supernova is both an ending and a beginning, a reminder of the cyclical nature of the universe. Stars like our sun end their lives gently, leaving behind white dwarfs. Imagine a small, dense ember glowing steadily in the vast dark. It no longer generates energy through fusion, but its residual heat shines softly, a subtle glow that can last billions of years. White dwarfs are fragile in appearance but resilient in duration. Surrounded by the delicate remnants of the Planetary Nebula, they act as quiet storytellers, holding within them the history of the star's life. Every atom carries the memory of the nuclear processes that occurred over millions of years. As you drift near a white dwarf, notice its calm presence. There are no eruptions, no explosions, only the steady release of stored energy. Time feels different here. It is elongated, expansive. A white dwarf is a meditation, a gentle reminder of continuity, persistence, and slow change. Over cosmic timescales, these remnants cool and fade, becoming black dwarfs. Though invisible, their existence shapes the gravitational landscape of galaxies, influencing the motion of nearby stars and planetary systems. Even in silence, the white dwarf remains impactful, a subtle force in the orchestra of the cosmos. White dwarfs, like all stars, have a legacy. The elements they produced, the light they radiated, the planets they nurtured, these continue long after the star itself has dimmed. In this quiet reflection, we see that a star's life is not merely measured by its brightness, but by the influence it leaves behind. The story of a star is not confined to its own life. Every star contributes to the ongoing story of the universe. Hydrogen, helium, carbon, oxygen, iron, these elements, forged in stellar cores, are the building blocks of planets, moons, and life itself. Imagine floating among these remnants, drifting through clouds enriched by countless generations of stars. Dust and gas, once part of a distant sun, swirl gently, preparing to form new stars. The universe is patient, deliberate, and continuous. Every particle carries memory. Every movement contributes to a rhythm billions of years in the making. Stars teach us about time, scale, and persistence. They endure for millions or billions of years, experiencing slow cycles of fusion, expansion, and transformation. Their light travels across the universe, connecting distant observers with events that occurred long before Earth existed. Even the most dramatic supernova leaves behind matter that will one day participate in the birth of new stars, planets, and perhaps life. This cycle is gentle, recurring, and beautiful. Creation and destruction are not opposites, but partners in the quiet dance of the cosmos. As we reflect on the life story of a star, notice the calm rhythm: birth, fusion, expansion, and eventual fading or explosion. Each stage flows into the next. There is no rush. There is only process, continuity, and the gentle unfolding of time. Now let us imagine a star as more than a distant sun. Picture it softly in your mind's eye. See its birth in a nebula glowing faintly. See it mature, steady, radiating warmth and light. Observe its expansion, the gentle shedding of layers, and its quiet legacy. Every star we see in the night sky has traveled through these stages. Though we observe them in a single moment, each light carries stories that span millions or billions of years. Every twinkle is a whisper from the past, a gentle echo of cosmic history. Consider your own life as a star. You too follow rhythms, cycles, and quiet transformations. You leave traces in the world around you, influence unseen yet significant. Much like a star dispersing elements across the cosmos, there is comfort in this parallel, a reminder that even in vastness, connection and legacy endure. The life story of a star, told softly, reminds us of patience, beauty, and continuity. It teaches that beginnings and endings are both meaningful, and that even in silence, influence persists. As our journey concludes, imagine floating slowly among stars. Nebulae drift nearby, glowing faintly. White dwarfs hum with residual heat. Supernova remnants radiate memory across the void. Everything is calm, deliberate, and enduring. Take a deep breath and let your mind move with the stars. Drift past galaxies, past swirling clouds of interstellar dust, past suns in every stage of life. Notice the gentle rhythm of the universe. Each star is a note in a cosmic symphony, a slow, steady melody that has played for eons and will continue for eons to come. Feel yourself connected to this vastness. Though small in scale, your awareness stretches across time and space, joining the quiet, persistent story of light, energy, and transformation. Here, the universe is not overwhelming. It is nurturing, serene, and infinitely patient. Allow the beauty